Section 9.5 continued, simplifying complex fraction notes. For these, there's a couple of steps that we're going to follow, and for these, you're going to want to write down these steps. So the first step, we're going to find the least common denominator, to find the LCD of the denominators. And then after you do that, you're going to multiply all numerators and denominators by the missing LCD factors. And then you're going to simplify. So if we look at this first one, number one, you notice that we have a fraction divided by fraction. So we have really 1/2 over divided by y, 1 over x divided by y, which is really y over 1. So remember, if you have a fraction divided by a fraction, this is really 1 over x divided by, and this says y over 1. And we know how to solve these. We've done this before, so all we need to do is take the second one, put multiplication here, and multiply by the reciprocal. And so when you do this, numerator times numerator gives you 1. Denominator times denominator would be x, y. And then this right here would be your solution. So now these problems are going to start to get a little bit more complicated. Now, if we look at number 2, notice that we don't just have a fraction divided by a fraction. We have a fraction divided by, or a fraction which is 3, divided by a binomial. So that means we always want to get this into a fraction divided by a fraction. So that means for this denominator right here, we're going to want to combine that into one fraction. So if I ignore the numerator there, ignore the 3, I'm going to look at the 1 minus 2y, and just like we did in the last section, I want to combine this together. So in order to combine this together, I need to find my least common denominator. So the 1, remember, is really over 1, so you could say 1 over 1. So what's the least common denominator between 1 and 2y? It's going to be 2y. So that means I need to multiply this fraction by 2y over 2y, because it's like multiplying by 1, so it doesn't change my equation. And that enables me to get a common denominator. So I have 2y over 2y minus 1 over 2y. And then remember, when you're adding or subtracting, you combine things in your numerator. So in this case, we have 2y minus 1 all over your common denominator, 2y. So that's what I'm going to replace this part with right here and rewrite my answer. So I'm going to make that a little bit smaller. I guess I can't make it smaller, but that's okay. Just move it back. Okay, so if I now rewrite this equation, I can rewrite it as 3 divided by, and now I have 2y minus 1 over 2y. Now notice that I have a fraction divided by a fraction, so I have 3 divided by all of this. When you have it written like that, then you can multiply by the reciprocal of the second term. But until you have it written like this, you cannot. So at the beginning stage right here, because I have this binomial and it's not one term, I cannot flip it yet. So now I can go ahead and flip. So I have 3 over 1, if you want to write the 3 like that, multiplied. I'm going to flip my denominator. So I have 2y in the denominator, that's going to go in the numerator, over 2y minus 1. And we have solved these before, so now I can do what I did before. I take my numerator times numerator, denominator times denominator. So in this case, I have 2 times 3 gives me 6y in my numerator over, and then 2y minus 1 times 1 is just 2y minus 1. And then you would look to see if you could refactor it and cancel out terms, but you can't. So this right here would end up being my solution. So let's go to the next example. So I'm going to erase this so I got some room here. So again, we're going to have to do the same thing that we just did in the last one. I want to have a fraction divided by a fraction. So if you look here, I need to make this numerator all into one fraction, and I need to make the denominator all into one fraction. So I'm going to show you two different ways to do this problem. The first way, you're going to want to just look at the numerator first, and we're going to deal with that one. So if I look at just the numerator, I have 3 over x minus 2 minus 5. I want to combine this into one fraction, so I need my least common denominator. This 5, remember, is really over 1, so what's common between x minus 2 and 1? It's going to be x minus 2. That means that the missing factors over here would be x minus 2 over x minus 2. So then when I combine that and rewrite it, I would have 3 over x minus 2 minus 5 times x minus 2 all over x minus 2. Now that I have a common denominator, I can put all of this over my common denominator, and I can combine stuff in my numerator. So if you look right here, this times this gives me 5x, and then this times this would be minus 10. So I have a negative right here as well that I am going to have to distribute to both of those terms. So we have, in this case, in my numerator, 3 minus 5x, and then you have to distribute that negative, so that would be plus 10. And then I'm not done because 3 and 10 are like terms, so that's really going to be equal to, I have my common denominator, so x minus 2, and then in my numerator, I have negative 5x and then plus 13. So that's all for my numerator. Now I need to do the denominator part. So for my denominator, I'm going to do the same thing. So if I look here, I have 2 minus 4 over x minus 2. 2 is really over 1, so I need the common denominator, which would be x minus 2. That means that I'm going to multiply this by x minus 2 over x minus 2, because multiplying by 1 doesn't change your equation. When I do that, I get 2x minus 4 over x minus 2 minus 4 over x minus 2. And then now I have my common denominator, so that's going to be x minus 2 down here. And then in my numerator, we have 2x and then negative 4, and this is minus 4. So negative 4 minus 4 would be minus 8. So all of that is going to be in my numerator. But I'm not done, because remember that this right here is in the numerator and this is in the denominator. So really I'm dividing those two. So if I write it as one big fraction, we have negative 5x plus 13 over x minus 2 in your numerator, all being divided by 2x minus 8 over x minus 2. Now that I have a fraction divided by a fraction, I can go ahead and multiply by the reciprocal. Whereas before, again, since I have that minus sign, I have a binomial and a binomial, I could not do that. So it has to be combined as one fraction because of this minus sign that separates the two. So I still have binomial in my denominator, but because we have two terms here that are not in the same fraction. So you always want a fraction divided by a fraction. I guess that's what I should say. So over here we have, we're going to flip this. So I'm going to make some of this smaller. So give me just a second to do that. Okay, well, I couldn't figure out how to make it smaller, so I just moved that over, which is fine. So make sure you keep all the work on your paper. So now I'm going to multiply by the reciprocal of my denominator. So I have negative 5x plus 13 divided by x minus 2 times, I'm going to now take what's in my denominator here, and that gets flipped, and I'm multiplying by the reciprocal. So x minus 2 over 2x minus 8. Now, since this is multiplication right here, and I have the same term here in my numerator and denominator, remember I can cancel out common factors. So this cancels out with this here, and then if I multiply across, I have negative 5x plus 13 over 2x minus 8. And I'm not done because I want to see if I can simplify this any further. So if I look here, my numerator doesn't factor. My denominator I can take out 2, so I would get 2 times x minus 4, but that doesn't cancel out with anything from my numerator. So I can leave this as my answer right here since that doesn't factor at all. So this would be my solution. So that is one way to solve this problem. Now, there is another way to solve the problem, which I'm going to do below right here. So you might want to just write this on the back of your sheet, and then because I'm going to eventually erase it so that I have room to write the next problem. So we have 3 over x minus 2 minus 5 all being divided by 2 minus 4 over x minus 2. Now, the second way that you can solve these problems is by finding the least common denominator of everything in your whole entire problem. So the least common denominator between all of my denominators, the x minus 2, 1, 1, and x minus 2, would be, of course, x minus 2. So what I can do then is I can multiply both the numerator and denominator by my least common denominator of all of the denominators. So x minus 2 over x minus 2, because multiplying by 1 doesn't change my equation. And so I'm going to multiply this into each of my equations. So when I do that, the first thing I'm going to do is take the x minus 2 here, and it gets multiplied by this term right here. So if we're multiplying that over by that term, you would have 3 times x minus 2 over x minus 2, and then minus, for the next one, you would have this times this, so minus 5 times x minus 2 over 1. And then this is all going to be divided by, now I'm going to do my denominator. So now I have this x minus 2 times this one right here, which gives me 2 times x minus 2 minus, and then I have this factor multiplied by x minus 2, so 4 times x minus 2 over x minus 2. Now for this, I'm going to go ahead and simplify. So when I simplify this fraction, notice right here I have the x minus 2 over x minus 2, which cancels out. This cancels out, so I'm left with, in my numerator, 3 minus 5 times x minus 2 over 1, which we don't really need to write, and then this one would be 2 times x minus 2 minus 4 over 1, which we don't need to write. So then notice that I could keep on going, so then this simplifies into, this would distribute here, so I'm going to write it over here. So we got 3 minus 5x plus 10 over 2 minus 4, which gives me negative 5x plus 10 over 2 minus 8, or 2, I forgot the x, sorry. So that should be 2x minus 8. Notice that this right here, and that should be 13, not 10, because 10, so that's going to be 13 because we have the 3 and the 10 right here. So notice that that is the same as what we got right here. It was just a different way of doing the problem. And I tend to like to do both of them. It just depends. Sometimes it's easier to do one way than it is to do the other. So we're going to practice both ways again for number 4. So, and if you get stuck on these, write everything down, and then you could always watch the video again. So let's go to number 4. And like I said, I'm only erasing this because I need room to write this next problem, but you should have this on another sheet of paper, or you can put it on the back side of your paper. Okay, so let's do both methods. Let's do the method that we just did for this next one. So if I look at this problem, I want to find the least common denominator of everything here. So notice I have this is over 1 and this is over 1. So we have x, y, and 1. So the least common denominator of everything is going to be, of course, xy. So that means I would multiply this by xy over xy. Now when I do that, this gets multiplied here, and then we're going to multiply this by this term and by this term. So for the first one, we get xy over x plus 3xy over 1, all divided by, now I'm going to do my denominator, so we have 5xy over y plus 4xy over 1. Now I'm going to simplify my terms. So if you look at this first one, the x over x is being multiplied, so that can cancel out. Y over y is all multiplication. There's no addition or subtraction there, so those cancel out. So now I can go ahead and start to simplify. So right now I have y plus 3xy all divided by, and that's over 1, which I don't need to write, all divided by 5x plus 4xy. Now notice I have just one fraction, so then I can go ahead and see if I can simplify anything. Those are not like terms at all, so since none of those are like terms, none of that is going to be able to do anything, so that's going to be my solution. I can, in my denominator here, factor out x. If I factor out x, I get 5 plus 4 y, but that doesn't cancel out with anything from my numerator. So since it doesn't cancel out, I mean, in my numerator, I can factor out the y. This would be y over 1 plus 3x, and again, that doesn't cancel out with anything. So then this would be my solution right here. Whoops, I didn't mean to erase that. So this was y plus 3 x, y. And so since nothing can factor and recancel, that is my solution. So that's one way to do this problem. The second way, which you can write on the back side if you need to, would be to get a common denominator just between your numerator. So if I look here with this first one, I can multiply 1 over x by my common denominator, my numerator would just be x. So I'd multiply this by x over x. Down here, my common denominator between y and 1 would be y, so I'd multiply this by y over y. So when I do that, I would get for my fraction 1 over x plus 3x over x, all divided by 5y plus 4y over y. And then now I have common denominator, so this would be 1 plus 3x over x, and then all divided by 5 plus 4y over y. Now I have a fraction divided by a fraction, so since I have a fraction divided by a fraction, I can multiply by the reciprocal of the second term, so this would be equal to 1 plus 3x over x times y over 5 plus 4y. Now that I have that, I can go ahead and multiply my numerator times numerator, denominator times denominator, because you notice that nothing cancels out right here. So that's where we get y times the 1 gives me y, and then y times 3x gives me plus 3xy all over, and then we're going to multiply the x times both those terms, so 5x plus 4xy. And notice that this is the same as what we got up here. It's just two different methods of doing the same thing. Now, generally, I like to find the least common denominator of everything and get rid of it because it seems to be a lot easier than doing the second way that I just did. But both solutions are correct and both will work. So again, make sure you keep that. I'm going to erase it just because I want to be able to do the next problem. And like I said, if you're having troubles, you can always watch the notes again. So then let's do number 5. And I'm going to do number 5, again, the way that I like to do it, which is just getting the least common denominator of all the denominators. So if I look at number 5, I have x, x plus 1, x minus 1, and x plus 1 in my denominator. So the least common denominator of everything would be x times x plus 1 times x minus 1. That's what I'm going to multiply both the numerator and denominator by. So x times x plus 1 times x minus 1 over x times x plus 1 times x minus 1. And again, the reason I'm doing that is because that's like multiplying by 1, so it's not going to change my equation. So now that I have that, I'm going to take these terms and I'm going to multiply this whole top x, x plus 1, x minus 1 times this first. So that's going to be equal to x minus 2 times x plus 1 times x minus 1 all over x. And then we have minus 2 times x plus 1 times x minus 1 all over x plus 1. That's just my numerator. Now I'm going to do this part right here and multiply it by that. So that's going to be all divided by, so now I'm going to do the second part, which would be 3x times x plus 1 times x minus 1, all divided by x minus 1. and then minus, and then the next one's going to give you 1 times all of that, so it's just x times x plus 1 times x minus 1 all over x plus 1. Now I can start to cancel out common factors, and the reason that we did that is because it allows us to get rid of those two fractions. So if you look here, notice x, and that's being multiplied by everything, so you can cancel those out. If there was addition or subtraction and it was attached to something, you couldn't. So here, this term and this term are being multiplied, so those are going to cancel out. I also have this term and this term that can cancel out, and this term and this term cancels out. So now I need to go ahead and to simplify this. I'm going to extend my page here. So when I do that, if I look at the first fraction, for the first one I have in my numerator x minus 2 times x plus 1 times x minus 1, and that's being subtracted by 2x times x minus 1, and that's all being divided by, now we have 3x times x plus 1, and then subtracted from x times x minus 1. Now, I'm not done here because remember, I can't cancel out some of these terms. Like this cannot get canceled out with this right here because notice that we're subtracting. These are two different terms. And same thing with this cannot be canceled out with this term right here because of that subtraction sign. So that means that before I can do anything, I need to combine my terms together. So when I combine my terms together, that means I'm going to have to multiply them all out. So I need to multiply this times this first. So I'm going to do that off to the side. So x minus 2 times x plus 1, you can use the box or FOIL method. I'm just going to go ahead and use FOIL. So x times x gives me x squared. That would be plus x minus 2x, and then minus 2. So that gives me x squared plus, or minus x, minus 2, sorry. And then this is going to be all multiplied by x minus 2, or no, x minus 1, because we already did x minus 2. So then, now when I multiply this, I have all three terms, so I'm going to FOIL it again. X squared times x would give me x cubed. X squared times negative 1 is negative x squared. And then we have minus x squared minus plus x. And then we have minus 2x plus 2. So then I want to combine my like terms. So my like terms here would be x cubed minus 2x squared, then minus x and plus 2. So that was these three terms right here that I just multiplied out. So I'm going to write that here. So x cubed minus 2x squared minus x plus 2, and then I can multiply 2x times this, so it's negative 2x, so minus 2x squared, and then minus 2x times negative 1 would be plus 2x. Now I'm going to go ahead and do the same thing I just did in my numerator, my denominator. So in my denominator, I need to multiply this by each of these terms. So that would be 3x squared plus 3x, and then I need to multiply negative x by this term and this term, so I get negative x squared plus x. And I'm going to keep on going because I still got to combine like terms. So in my numerator, I have x cubed, there's no other x cubes, but I have negative 2x squared and negative 2x squared combined to be minus 4x squared. And then I have minus x and plus 2x, which is just plus x, and then plus 2, all divided by, and in my denominator I would have, we have 2x squared because these combine together, so 2x squared, and then the 3x and the x combined to give you 4x. So before I say that this is my solution, I would want to see if I can factor this and simplify it any further now that I've combined everything together. So if I look and try to do factor by grouping with x cubed minus 4x squared plus x plus 2, so if I factor or group these two together and group these two together, I can factor out x squared here, and that would be then times x minus 4. And then notice that you can't factor anything here, so this would be like 1 times x plus 2. So since nothing right here, this is not the same as this, that does not factor, so I can't factor that term. So I'm just going to erase this here. If I look at my denominator, in my denominator I have 2x squared plus 4x. That does factor. I can take out 2x from each term, so that would be 2x here, and that would then give me x plus 4. But again, my numerator didn't factor at all, so I can't cancel any of these terms if I were to rewrite it. So this right here, that means is my solution. So make sure that you look at both of those, ways of doing these problems and kind of make sure if you missed something or was confused, I would watch the video again. I want to go back up here though to question number 2, and I solved that the first way. So if I want to solve this the second way, I'm going to do that off to the side up here. So for this one, another way to solve that problem would have been if I have 3 over 1 minus 2y, I want to find the least common denominator of all my denominators. So 3 is really over 1 if you want to write that, so that's like 3 over 1, and this is 1 over 1 minus 2y over 1. So my least common denominator of all my denominators would be, in this case, 1, so that doesn't really help me out at all. So that wouldn't really do much for my problem. So in this case, that's why for this one, I didn't do the least common denominators of all of them. That's why for this one, I had to just do the denominator by itself, and I would have to figure out, oh, it was 1 over 2y, that's why I was going to say. My bad. So then, okay, so for this one, if that was the case, you couldn't do that, but this would be 1 over 2y. So the least common denominator between all your denominators would be 2y. So if you multiply this by 2y over 2y, that would give you 3 times 2y is 6y over 2y times the 1 would be 2y minus, and then you would get 2y over 2y, which is just 1. So 6y over 2y minus 1. This is the same thing as what I had over here, just a second way of solving.